let's say that I have to do I mean, which factors mostly most influence healthy lifestyle. This is my goal, which factors. So what I'm going to do is I'm going to create a cluster. So I have two things. I will just create one cluster called lifestyle factors. Lifestyle, and I will name it as L. Then I create another factor called social environment factors. Yes, and I will just name it as S. And I change the color of this one so we can distinguish the both. So in under the lifestyle factors, I can put several sub levels or sub criteria. I would say regular exercise, and I can put something like balanced diet. So this is my L1, regular exercise, and the balanced diet is going to be my L2 under L. And for the social factors, I am going to list down two things. Under S1, I would say peer influence, and as my S2, I can name something as community facilities. Community facilities. Okay. So these factors influence each other as well. For example, if you take a look at the peer influence, this one, peer influence affects your exercise habits, and having access to gyms, community facilities encourage healthy eating too. So these are all connected as well. Now, the first thing that we have to do when we are dealing with HP or NP, we said we group them together, paste it as a figure. Okay, so this is my levels and the goal. Then my step one is to actually step one would be an HP style pairwise comparison within each cluster. Okay, so within each cluster. So in my case, I have the lifestyle factors and within each cluster. So I have the exercise part and the diet part within this cluster, lifestyle factors cluster. So I have to draw a table. It's a simple table. So I will name L1 here, that's exercise, and L2 here, that is diet. And I will again put this L1 and L2 here. I don't need this part for now. I will delete this is my issue. Let's say L1 and L1, that is the same. I rate it as 1. L1 and L2, I rate it as 2. I think L2, L1, that is exercise, is more important than balanced diet. And then because this is 2, I have that balanced diet is half important as L1, and then L2 is 1. So this is basically what I have. Now the next task is to normalize each column and average rows. So I will take this thing, right, the same thing. How do I normalize this one? I add 1 plus 0.5, and that gives me 1.5. Then I can divide 1 by 1.5. So the answer will be 0.67, something around that. And for 0.5, that is 0.5 divided by 1.5, that is 1 over 3. So that's 0.33, this one. I just color this differently so that we know that we have done the math. So 0.5 is 0.33, and this is 0.16. So 67 the same. I think because it's 2 divided by 3. 2 plus 1 is 3. So here it's actually 2 divided by 3 plus 1. That's 3. That's going to be 0.67. And for the last part, it's 0.3. So we have a matrix, a normalized matrix. So this is a normalized matrix, normalized columns. And the next thing is we have to get an average weight. So to do that, I will insert a column to the right, and this will be my average weight. So how do we get the average weight? You now obviously you can go with the geometric mean part, but I'll go with the average arithmetic 6, 7, and this is going to be 0.30. It's the same thing. And I like to indicate that it is the average weight, right? So this is for the L2, L1, that's lifestyle factors. I can do a similar thing for the S case as well, that is for the social one. And let me put the last one for that as well. This is the social one. And these were my average values. I just put the average values so that we don't need to go through the same thing again. 0.25, 5, 0.75, no money, 5, 0.75. Right, so that is my step 1 HP style pairwise comparison. Let me go to the next part. So I will just make it a group. So my step 2 would be intercluster influence. So that is where the ANP comes into picture. If I clearly write it, that's basically step number 2 to check. This is not within cluster, this is intercluster influence. So this is the ANP. And the question is, right? The question would be, do lifestyle factors influence social factors? And vice versa. So that's our problem. This basically the L and S are connected, or S and L, the degree of influence. So we'll look at the connectivity similar to the previous case. I have developed so basically another table, and this table contains the social L1 and L2, but instead of L1 again with L1 here, we have S here and S2. So unlike in these cases, we are comparing intercluster. So if S1 and L1 they are having the same weight, that's one. If let's say L2 is like S1 is not important as S2, so let's say 1/3, and because it is 3 times now, this is the same thing. You just fill in the table with the intercluster influence, and then the next task is to normalize this. So we take this, the normalization happens 1 plus 3, that's 4. 1 divided by 4, that's going to be 1 divided by 4, that's 0.25. So I have a table that I created, so I'll just put the values as such: 75, 0.94, 0.86, other than so this is my normalized social to lifestyle influence. So remember, in this case, my columns, I'll write it down. My columns are, look at the first column. This indicates the important one. It means we are now looking at the dependency of social to lifestyle. Okay, look at the first column. This one. We are looking at the influence of social part to the lifestyle, which means whatever that you put here, obviously, like in the H3 case, whenever you put a value, large value here, it means this one is more important. So if you have, for example, here 0.7, all the values here indicate that these are not that important when it comes to social to lifestyle. So 0.75, like 3 times here. Social S2 is 3 times more important than L1. So in that case, S2 is balanced diet. So it's more important. So S2 is community facilities. Sorry, community facilities 3 times important than regular exercise. So that's what it says. Okay. So that's interclass dependence. So I will keep this as is, and then I will move to the next one, the same class dependency. Now we have to look at it from the other way around, that is from the lifestyle side. So now my columns become L, and my other things become SS. That is, I'm looking at the life. I'm looking at the importance of lifestyle towards the social, comparing based on lifestyle, looking at social part, right? And let me delete this one, and this will be my new thing. So these are all values. So let's put in new comparison values. So lifestyle L1, I think they are similar, and I think L1 regular exercise is not that is half important as the S2 social community facilities, and L2 is the balanced diet, and it's equally important as the peer influence. But I think the balanced diet is 2 times more important than the S2 as community facilities. So now I have to take these values and normalize them here. So I have to normalize 1 divided by 1 plus 1, that's 2. 1 divided by 2, that's 0.5. The same thing is here, 0.5. And now half plus 2, that is 5 divided by 2, right? Yeah, 5 divided by 2, that's is it 2.5? So it's basically 0.5 divided by 3.5. That's 1/5. That's equal to 0.2. And this is 2 divided by 2.5, 0.2. I'll put this in a different color. They are related. So this is now I have, this one is the normalized one for social to lifestyle. This is the normalized one for lifestyle to social. Right. So I have to normalize it. Now this is the part where we take everything and build on what we call this supermatrix. So what do we have? We have normalized this matrix that's social to lifestyle. Then I have this matrix that is lifestyle to social. Right? These are the two inter-class comparisons that we have. So L1, L2, S1, S2. Now we develop this supermatrix. So now we are going to develop the supermatrix and matrix, and that is unweighted. Right. Space. Right. Now we are going to develop the supermatrix. So how do we develop the supermatrix? We do a 4x4 matrix, but I take 5 by 5 to put the values. So here we follow the same order: L1, L2, S1, S2. So L1, L2, that's how we did it, L1, L2, and this one is S1, S2. Here again, this is going to be L1, L2, and then S1, S2. Same thing with more expansion. So now here from slash 2, which means L1 to L1 and L2 to L2, L1 to L2, so and so. So from L1 to S1, what was the value? L1 to S1, the value is 0.5. L1 to S1, the value is 0.5. And L1 to S2, the value is 0.2. That's what we got from. And then from L2 to S1, that is 0.5 and 0.8. So I just directly copy this. And from S1 to S2, S1 to L1 and L2, you have L1 0.25 and 0.1. So that is from S1 to S2. Right? And from S2 to L1 and L2, you have 0.75, 0.86. That's what we have here. Okay. So how do we fill in this S1, S2 thing? These are the values. So let's check whether we have any such comparison before. So we have a comparison that states this L1 to L1 0.67, L1 to L2 0.67, L2 to L1 0.33. So this is that matrix. See? And I'm going to fill it here. And for the S1 to S2, here you have 0.25, 0.75. That comes from interclass within intraclass within each cluster comparison. So now, as you can see, different colors indicate where the values are. Right? And the next thing is step number 4. You can do this by step number 4. We will normalize columns. So how do we normalize columns? We have to divide each cell value by the sum of it. So I will type it here. The Excel formula to do this. To do this is cell value divided by sum of column. I will type in the sum of the column. So sum the column and cell value is divided by that. So each column should add up to 1. That's the idea. This column should add up to 1. And once you do that, so let's try to do this. We'll go with the hand calculator. Now I need an Excel. So this is what I have. Okay. And to make it simple, I'll just remove the analysis. So this is my supermatrix. And now I need to make sure that I put this as a normalized one. So how do we normalize it? We have to divide by the column sum. So I will get the sum here for the column and for each column. Okay, nice. I got 2 for everything. Yes, good. And then I divide each of these cell values by that sum. Then we'll put it here. That's my divide by that thing. Because it's 2 everywhere, I just without any issue, I will just take it from here. Because it's 2 for all the cases, so it's fine. Otherwise, you have. So I have a supermatrix. Now is the fun part. I have to multiply, do the matrix multiplication for this supermatrix. So I have to multiply this one with itself. So let me do that with matrix multiplication in mult. Array is this one, right? Comma, the same array. The same thing, matrix multiplication. and I have to just keep on doing. So this is my first thing, so I will make this color like that, so color like this. This is my first multiplication, and I will do the same set of. So you can see I get a similar matrix. I'll color it differently. Same. Now, as you can see, if I check my orange color and this orange color and the blue color here, let me do a small comparison. If I reduce this one like that, as you can see, they become very like minute. There's no change. They are very small, right? These are very small values, which means we have a convergence. So something very, very small. So what does it mean? If you have your final priority, these values, you take these values as your priorities, and this one is L1, this one is L2, then S1, and S2. So at the end, we come up with this rank, which I can just take it, right? And I'm going to paste it as these values. And as you can see, if I arrange them in the order like custom sorted, and now I have my ranking, which means I have my S2, which is the, now let me take it to my matrix in the Excel. I'll go to the very first one where we have these definitions. Paste it as ANP. So what does it mean? It means that community facilities are more important, and then followed by L2, which is balance diet, and then L1, regular exercise, and S1, that is peer influence. So that is how you do an ANP in a very simple way. So if you have multiple authors, multiple experts giving you opinions, then you have to have a way to get these average weights and average matrices from there. That is the problem. So that pooling decisions, you follow the same thing that you do with the AHP, and you create this matrix. The first one, interclass matrix and intraclass matrix within each clusters first, and then go for the supermatrix. I hope that is clear.